सर
अभी एक
आप होस्ट हैं।
हाँ अब हो गया ठीक
ओके
है
सर, ओके सर, प्लीज प्लीज कैरी ऑन।
ओके hello, welcome back again. Can you see this screen? Please inform me through chat. Can you see? Okay, now let's start. Now dear friends, welcome back. Recording, remote control. Wait for 1 minute. हाँ, ये रिकॉर्डिंग वाला कहाँ से होगा फिर बताओ जरा। हो रहा ठीक है, थैंक यू। ओके, वेलकम बैक। कैन यू हियर मी? जस्ट टेल मी थ्रू चैट, सो आई स्टार्ट। Okay, thank you. Now I start my lecture, dear friends. So in this particular case study, we have 810 participants, and all the 810 participants participated in a music festival. Okay, so in this part is you can see there are 3 days data: day 1, day 2, and day 3, and all the participants stayed 3 days in a particular place. So now the biologist wants to know the hygiene condition of day 1, day 2, day 3. Is it clear? So this particular uh, biologist wants to know the hygiene condition the particular place, and the respondent, all the respondent given their responses in a uh, 0 to 0 to 4, between the 0 to 4. It means if someone is giving his response 2.5, it means he is more or less satisfied with the hygiene condition of this particular uh, staying location. Okay, so there are this the day 1, the all the 810 participants present there. Day 2, you can see some participants were not there, missing data. Here day 3 missing data. Okay, so we have 3 days data of 810 participants. Now we should uh, find, estimate descriptive statistic. So how to create descriptive statistic? Now we can see here analyze. We go to analyze and then descriptive statistics. So you just follow analyze descriptive statistics, and here you can see descriptive. Okay, so this descriptive, I selected all the 3 variables, and I selected all the 3 variables, and so not I am not selecting all the 3 variables, I am taking only one variable. Here one variable, I want to know the descriptive statistics of day 1. Okay, so this is option. Here I want to know in a descriptive statistics, because descriptive statistics can be done in many ways in a SPSS. One, mean, standard deviation, minimum, maximum, uh, variance, range, standard error, kurtosis, skewness. So we can do this way, or there is some another option also. Now this is our output. Now output, what would be the output? This is our output. Okay, now I am sharing the output of my this particular data. So I am stopping the SPSS file, and I am sharing the output of my data. The output, so my output is, I can see here output data. I am finding just this is my output, and I am sharing the output of my data. So the output means in a descriptive statistics, we can find here 810 respondent, maximum score given by 20.02, minimum, maximum, mean, standard deviation, variance, skewness, and kurtosis. So there are another method I will use to find the descriptive statistics. This is I'm using here analyze descriptive statistic, and third is this one is another method. Here I am transferring this particular variable into the dependent list, and there are some options you can see here. Descriptive statistics, here descriptive be by default, it means we do not need to take mean, median, mode. So it will give central tendency, measures of dispersion and distribution. So this is much better than previous. So here it is by default giving the descriptive statistics. We can continue it, and then plots. So we can get histogram, although we do not know, but we can get the histogram, and then options. There is no need, there is no missing value. If we have missing value, then we should tick this one, exclude case pairwise. Here we do not have we don't need to tick it because we have all 810 data. There is no missing value in a day one. Now we have missing value day 2 and day 3. Okay, now this is my I will take it okay, and I will show my output, how my output will look, how this particular my output. I am sharing the slide of my output. Okay, so here uh, the output of I am stopping the slide, and I am showing the output. So this is my output. I think, is it visible to you? Can you see this descriptive statistics? So you just tell me through chat box. Okay, thank you. So here we can see descriptive statistics. I told you there are three things in a descriptive statistic. One is mean. Mean means all the 800 respondent, 810 respondent give their responses, and 1.7 means their responses was 0 to 4, and the mean value, that is 1.79. It means they are not fully satisfied. Okay, and second thing, that this is 95% confidence interval for mean. It means this is the lower limit, and 1.72, and upper limit 1.852. It means if we take 100 sample mean out of 100, then 95 sample mean would lie 1.7 to 1.85. It means this is the range. And 5% trimmed mean, if we cut 2.5% extreme observation of left tail and 2.5% observation of right tail, then our mean would be 1.719, and then median value 1.79, variance we can see here 0.892, and standard deviation 0.9449, and minimum. Now here we can see the minimum minimum rating given by 1%, that is 0.05, and here maximum given by a respondent, that is 20.02. But 20.02. It means we have given choice respondent to fill 0 to 4, but someone entered 20.02. It means it is outlier. It means this observation not part of our study. Now we can see how will we find this particular person who has given 20.02. We have already told them you should give or your opinion between 0 and 4, but someone given 20.02. Okay, so how will we find, because it is very difficult in a 810 respondents, how will we find this particular person? So there is a one we can find. There is it is box plot. Sorry, box plot. This is our box plot, and the maximum people give their opinion 0 to 4, but this particular person 682 number of respondent, he has given his option 20.02. So through this box plot we can identify outlier, and then we correct our data. Now you just see what is the skewness here. You just note down the skewness is 8.865, kurtosis 170.40. Is it clear? You should note down these values 8.865 and 170. It means for then our objective to find this particular person who is the who. So we will find in our we will find that particular person who is. So we will see our this sheet. The person number, the person was 682. Okay, 682 means the that person belong to the 682. So we go to data. How will we find that particular? So we go to data, and then case short, we will find that particular short variable. We will identify select case. This is select case. Okay, then select case. This is my element. I will identify that person. So I am identifying data. Go to case. Here, go to case. Is it written somewhere? I think go to case. View, edit. Sorry, edit. So we go to edit and go to case. Here we will find that particular individual, and we will type here 682, because through graph we identified him, and here we will write 682 and go. Now cancel this one. This is the person who has given the 20.02. Now we can correct it. Actually he was giving 2.02, but by mistake he entered 20.02. So I will remove it, and I will share I will save my file, and again I will find the descriptive statistics. Okay, so how will I find? Then I analyze and descriptive statistics, where descriptive statistics, and explore. Okay, so in a descriptive statistic, by default it was in the dependent list, this particular variable. Descriptive statistics, continue, plots, histogram I need, and then option, nothing to do here, and then okay. I will show my result. I am stopping this slide, and I am sharing output. So I am selecting output, my output. This is my output. Here I am sharing output. Now I think you can see this particular output. Now I told you that you note down the value of skewness and kurtosis. Earlier it was 8 point. Skewness was 8 point something and kurtosis was 170. Out of 810 respondents, only 1% given wrong number, and through this the whole statistics changed. So because skewness and kurtosis, what does it tell? Skewness क्या बताता है? The value of skewness and kurtosis ideally between -1 and +1. If our data now our data, we can see this is our graph histogram. Now earlier our data was not this pattern. The pattern was something different. Now we can say here the this particular data, it is normally distributed. It means normally bell shaped. But when we compare with the previous data, so our data was not normally distributed. It was not normally distributed because one observation, you can see here 20 point something. So due to only one influencer, one outlier, our whole statistics change. And you can find in earlier case when outlier was there, this was the box plot. But when we identify and remove and correct it, then our histogram and diagram. Now this is our clear picture. Is it clear? So we can understand only one variable create problem. Okay, this so we should identify outlier through box plot. We can identify, and through histogram we can identify the outlier. This is my outlier, but here we cannot find which particular case is there. So if we want to know the particular case, then this box plot will help us, and he identify and he tell about the particular observation. This particular person, basically it is this part, he has given the wrong choice. Okay, now we will create the histogram. We understood. Now we will create histogram. I am sharing my slide. So through this particular, I will share. I will create the histogram. So all the diagram we will make through the bar. This particular. Okay. So we will make the graph through. How will we make the graph? First of all, we will go graph, then chart builder. After chart builder, okay, and then histogram. Here we will find histogram. That is, we have selected histogram. There are many types of histogram, but we need only simple histogram. So histogram basically tell about the skewness and kurtosis of the data. Okay, so we will select this histogram and double click here, or we can drag and drop. So here I will take Heisen into x-axis, and it is histogram properties. So just I will enter histogram percent here, and then display normal curves. I will superimpose normal curve and apply, and then close. So I will make the graphs. Here I can see my graph, and then okay. So we can see our graph. This is my graph. Okay, this I am showing my graph. How I am stop sharing this slide, and I am showing the output. Okay, output. So I will show my output. So through this output we can learn how we create the graph. So here I am sharing my screen. This is my graph. Okay, so we can make graph. And second ओके ओके, मैं फिर से रिपीट के लिए स्टूडेंट्स क्वेश्चन है कि I should repeat again this how to create graph. Okay, so I am creating again. Stop sharing and I am selecting my data file that is here now. Now we can see here, dear friends. Again, you can see how to create graph. So first of all the graphs can be performed here in a graph. We will go to graph, then chart builder, here chart builder, and then okay. When we click OK, then I am resetting this. So there, if we want to make bar chart, line, area, scatter, but here we want to create histogram. So here I will tick here, and there are 4 types of histogram: simple histogram, stacked histogram, frequency polygon, population pyramid. So I will double click here, and then you can see the my variable, that is score of day 1. I will drag and drop into x-axis, and then in element histogram statistics I will select percentage on a y-axis, and then normal curve, for display normal curve I will tick here. Okay, if I don't tick it, then normal curve will not superimpose on a histogram. If I am ticking here, so normal curve will come. Okay, so this is the way to creating the graph. Now this is my graph. Now second case is this is about the graph of histogram. Now I am creating another graph, that is one bar chart. Then how to create this particular one bar box plot. Now I will create the box plot. Again, it is very important for us to make the box plot. How to create box plot? So I am sharing my sheet. Okay, I think you can see this particular sheet. This is can you see this particular sheet? Okay, graph chart builder, can you see? Please inform me through chat box. Can you see this data? I'm just asking. If you can see, please inform me through chat box. Okay. Okay. Now this particular sheet, I'm talking about this one. I am sharing again. Okay, okay. Now you can see there is no problem. Then okay. So this is my data. Okay. So I am creating here box plot. How to create box plot? We go to graph, then chart builder. All the graph will be created here. Then okay, and I will select here. I will reset it. I will reset it, and I will make box plot. So we will find here. You can find here box plot. Okay. So we will select it and double click it. When we double click, my graph will appear here. So I am selecting here the box plot. This is hygiene day 1 and gender, because so there are 2 ways. One, I can compare with male and female here. So there will be 2 graph, 2 box plot, one for male and second for female. Okay. Then okay, and after okay, we have another graph. So I am stop sharing this one, and I am showing you the graph output. This is my graph. Okay, so we can create graph. This is about the male respondent responses, and this female diagram tell us about the female. First one is male. You can see here male. and you can see female. These are the outliers, sorry, extreme cases. We can say extreme cases because it was the limit. 4 was the limit. It is not out the limit. These are the extreme case. Only few people give their opinion in a higher side. Okay, this is, we can say these are extreme cases. Extreme cases may be in a lower side also. So there are two way to detect our extreme cases in a upper side and lower side. If it is outside this whisker, these are treated as outlier. We can say outlier also or extreme cases. Okay. Now I will create the third graph, that is box and whisk error bar chart. So through this graph, I can create the error bar chart also, same data. Same data I can use for creating the bar chart. I am sharing my slide, that is same file I am using to creating error bar chart. How to create error bar? So we can go graphs, chart builder, and then okay. And after okay, here we can see same. So if we want to know the bar high low, this is dual line. So we can check the box plot. I am talking about box plot, element properties. This is, now here you can see, we can select two things, gender of the uh, participants and day one. Now box plot, mean, I will take here, there is a display error bar chart. So we can see here, this is the display of error bar, but it is not showing here. So we can take of error bar chart of another data. I will reset it, and I am making bar chart for bar. Okay, error bar. Then I'm checking, this one is my uh, data, that is day one score. It is, sorry, it is not, I'm taking data of gender, and then hygiene score on count and display. Here you can see display error bar. So I have ticket. How to create error bar chart? I have entered gender into the x-axis and hygiene day one score into y-axis, and then mean, because if I do not take mean, then error bar chart will not display. Is it clear? Now apply, and after apply, okay, then we can see error bar chart. So I will show my error bar chart through the through my this is my error bar chart. So I will share it you. Where is my error bar chart? You can see. So again I am using how to make error bar chart. You just go to graph, chart builder, how to create error bar chart. Again I am repeating the same thing. So bar chart, I am resetting. How will we create bar chart? Error bar in a bar chart. Double click, then gender into the x-axis, hygiene into y-axis, and then here you can see display error bar, and then apply, and after apply, okay. Now we can see the error bar. Okay, so I am showing the error bar, how this particular error bar looks. So we can see here. So this is our error bar chart. This is known as error bar chart. This is known as error bar chart. What does it indicate? It indicates that this is our mean value. It means if we take 100 sample mean, 95 sample mean will come under this region. Only 5% sample mean may come out of this, above this particular whisker and below this particular whisker. Okay, so this is about the error bar chart. Now we take another chart after this bar chart. How to create bar chart in our data? It is same as, so I have discussed you. This is the one. This is error bar chart and bar chart. Okay, this is we. Now next bar I will create the bar chart for two variable. How to create it? Bar chart for two variable. I am taking another case study. My case study name is chick flick. Okay, I am showing my data, and I will create the chick flick case study. The case study name is chick flick. So my data, how can I see my data? I am showing my data chick flick. This is my case study. I think you will see it very soon. I am stopping my this particular file, and you can see chick flick case study. What is this particular case study? You can see it. So screen share. So this is download music festival and my chick flick case study. I think now you can see this particular my case study. Case study name is chick flick. Okay, so you can see this case study. I think chick flick case study, is it visible to you? I think everyone can see. If, please tell me whether you can see this particular case study or not. I am just, I want to know. Yes, it means you can see this case study. Okay. Now this is my case study, and this case study tell about the there are two movie. One is Bridget Jones, and second is Memento. Okay, so there are two types of participants: male participants and female participants. Total number of participants 40, and out of 40, 20 male participants and 20 male. So in a 20 male participant, we offered 20 participants to watch the movie. 10 participants will watch this movie. That is the name of the movie. What is the name? Bridget Jones' Diary. And we offered another 10 participants to watch this Memento movie. Okay, and we told them every participants supposed to give their opinion or score. Okay, whether you like this particular movie or not. So respondent number one has given 22 22 out of 50, and 13, 16, 10. And in for second movie, the first male, that is, he has given 37 score, 27, 16, 28, 20. It means this movie is better than the previous. Now we will see the score given by the female participants. So female participants, again, first this particular female given number 3, 15. Okay, now another group of 10 female participants. This particular female giving 30, 25. It means this particular movie can be appreciated by male and female both. Then how to show this particular data into the graph? Because we can understand the male and female both are liking Memento movie, but if we present this data through graph, then it would be more fruitful for us. So we should prepare our data. We should prepare our data or show our data through graph also. Okay, so in a bar I will select bar, and bar for two variable. So I am selecting here. Now name of film, here I will take it here. Okay, name of film in x-axis, average physiological in a y-axis, and gender I am drag and dropping into this. Okay, so I can repeat again, no problem, reset. So here bar, this one is tagged or clustered bar. So I will take my bar into the chart preview box, and then the gender into the cluster on X, name of film on X axis, and on Y axis their score. Okay, now so we can see our graph, and we can understand the output of this particular data. I am stop this sharing and showing you the slide of my output. So my output, I am showing the slide. Okay, so my uh, output, this is my output. I think, uh, is it visible to you output? Can you see this output? Only one person can tell me. If you can see this output, there is no problem. Okay, you can see. Thank you, thank you, thank you. Now, so now I am interpreting this output. Through this output, we can compare our data. There are two types of movie. One is Bridget Jones' Diary, and second is Memento. Now here we can see in a blue, that is blue male, and green indicating for female participants. So this data shows that both the movie liked by, means in a movie male participants enjoyed more whether they were watching Bridget Jones' Diary or Memento movie. Okay, in this particular movie the score, although we can say that this particular movie less appreciated by male and female, but the mean score arousal here, this is the mean score of our participants. If we want to know, if we want to enter the value inside the box, so we will double click, and after double click we will double click, then we will choose here, we go to elements and data label. Okay, so data labels, and then we will tick here, tick here, here, here. So here we can see number inside the bars. It means the mean score of male participants was 17, and mean score given by the female participants was 12. Same as we can compare here. Okay, so we can enter our data uh, in a number form, in a frequency. So through B we can show our data. Now another graph, uh, I am checking the next, which is scatter diagram. I will create a scatter diagram, and then assumptions of parametric test, because it is very important topic. Before applying any parametric test, we should check data's normality and homogeneity. Okay, so I am taking only one graph, that is scatter diagram. I will do quickly, so you just follow the instruction. I am taking another case study for creating graph. Okay, so here the case study name, exam anxiety. I am showing this particular slide to you people. So here new share, I am sharing the my case study name, that is case study. What is the case study? Case study name, that is uh, 1 2 3 4 5. Okay, now you can see the case study name exam anxiety. Okay, now please tell me, can you watch this data code? uh, can you see this slide code? Revise exam anxiety gender. Please tell me. Please please inform me through chat box. Can you see this slide, exam anxiety 5? Okay. Yes. It means everyone can see this. Okay. This is so. Please, it's a very short case study. You just uh, go. You just listen this case study. In a case study, it is a data of 103 respondents. It means in this case study, we collected data from the 100 students, and there are variable means revision time and exam performance, and third is exam anxiety. Okay, so there are three variable: revision time, exam performance, and exam anxiety. And gender means male and female. We collected data from 103 participants in both male and females. Okay, so we, through this particular case study, we want to know, is it any relationship between revision time and exam performance? It means if particular student give more time to his study, will he get good marks in examination or not? Is it any positive correlation or negative correlation? Okay. Now, second is exam performance. Second is revision time and anxiety. Is it any relationship between exam anxiety and exam performance? It means if a person gives less time to his study, he will be anxiety will be higher or lower. I think if we are giving more time to our study, what would be the relation with the anxiety? Anxiety would be less or more? I think if we give less time to our study, anxiety will be high. If we give more time to our study, anxiety will be low. It means there is a negative correlation between the two variables. Earlier I told you the exam performance and exam revision time. More revision time, more exam performance. It means there is a positive correlation between. So how will we draw the graph? How can we see the, how can how will we create the scatter diagram for the two variables? So I am creating the graphs. I am going to graph and chart builder, and then after chart builder, okay, and okay, I will select here scatter. Okay, scatter. So first of all, I want to make only simple diagram. There are large number of scatter diagram. Means second one is grouped scatter, third 3D, for grouped 3D scatter, for summary point, for simple dot, for scattered plot, matrix, drop line. So we need only simple. I will double click here, and I want to see the relationship between the time spent on revision and exam performance. As we know, there is a positive correlation between the time spent on revision and exam performance. Okay, now we have taken time spent on x-axis and exam performance on, because it is depend on time. So dependent variable we take into the y-axis, and then okay. Now I will show you another graph, chart builder, then another graph for, this is the time spent, and I'm taking another variable, that is anxiety, time anxiety. How can we see relationship between the exam anxiety and time spent. Okay, so I am showing you the my graph. I am stop sharing my data, and I am showing you the output. Okay, so my output, what is output? Yeah, this is my output. Now we can see there are two graphs. One is time spent on revision, time spent revising, and exam performance. There is a positive correlation between the two variables. Now how to create the regression line? Or so I will double click here. After double click, so after double click, I will select element and fit line at total. Here fit line at total. So now we can understand whether positive correlation between the variables or negative. So here we can see in a this particular graph time spent on revision and exam anxiety. Okay, so this data tell us about the negative correlation between the two variables. So I was talking about this variable also. Okay, I am talking about this variable. So I will double click here, elements and fit line at total. So we can draw the regression line. So now in both the cases, this is our negative correlation. This graph shows negative correlation between the two variables, and this one would be the positive correlation. Means more time, if we give more time to our study, then exam performance would be high. So there is a positive correlation between the two variables. Now I am sharing my slides on parametric and non-parametric test. Within a 5 minutes, I will complete this topic also. This is my last topic of today lecture. The norm as normality and assumptions. Okay, so I am sharing this particular slide. So you just I am stop sharing my slide, and I am checking my PPT. That is, I think you can see this PPT exam exploring assumptions. Okay, I think, is it visible? I think you can see it. Is it visible now? So aims of the assumptions of the parametric test. Basically, what is parametric test and what are the assumptions of the parametric test, we should understand here. So basically, we should understand the normality of the data. How will I calculate or estimate the normality of my data? So there are three ways to estimate the validity of the data. Okay, so one is through graphical. Through graphs we can identify the normality of the data. So we can create histogram. Through histogram we can understand the normality of the data. Second is values of skewness and kurtosis. If values of skewness and kurtosis between -1 and +1, then we can say our data is normal. And third way, that is the third way is that is third way that is live normality test, KS or Shapiro test. Okay, so there are three methods to identify the normality of the data. One is through graph, and second values of skewness and kurtosis, and third is normality. So before applying any parametric test, we should check normality of our data and as well as homogeneity of our data. So there are two main assumptions of the homogeneity and normality and homogeneity of the assumptions of parametric test. Okay, so first data should be, what are the assumptions of normal and of parametric test? One, data should be normally distributed. Second, data should be homogeneous. Data should be collected interval or ratio scale, or data should independent. So we will focus here normally distributed and homogeneity of variance. How to interval means we can collect data interval or ratio. There is no problem. Independent means one particular individual score should be different from the another. Okay. Now normally distributed. So there are two things we should check. We should estimate. One is normality and second homogeneity. How to assess normality? I told you there are three ways. One is graphical display. Through graphical display we means histogram or pp plot, or probability plot, or qq means quantile plot. There are two methods to find the homogeneity, normality of the data. One histogram and second pp or qq plot. Second is value of skewness and kurtosis. This value should be -1 and +1. And third, KS test, Kolmogorov-Smirnov test, means p value should be greater than 0.05. So I am taking same example which I earlier discussed with you. This case study, a biologist was worried about the potential health effect of music festival. 810 participants participated in a music festival, and then they give their opinion 0 to 4. And 0 means you smell like a corpse rotting up, skunks, earth, and 4 means you smell of sweet roses on fresh spring. It means it is bad 0, and 4 means good. Okay, so how to create this? There are three ways. So I will create homogeneity or normality of the day 1 data, day 2 data, and day 3 data. Here we can see the day 1 data. This we can see here, this one is normally distributed because this particular box is normally because it is bell shaped. Bell shape means ghanti ki shape, and it is positively skewed day 2 data, and day 3 data it is positively skewed. It means it is not normal. It is not normal. Only out of the 3 days data, only day 1 data is normally distributed. So through and second way, to all the observation, if we want to find the normality of our data, so every observations, these observed or this error term should on the diagonal line. Okay, and then second, if these observations deviate from the principal diagonal, it means this is not the normal. If deviate from this principal diagonal, it means it is not normal. So third way, QQ plot, again it is same as the PP plot. All the observations should lie on the this particular principal diagonal. If it is deviate and curving, then we can say it is not normal. Okay. Then value of skewness and kurtosis. Now my data showing that the skewness, that is -0.004, and kurtosis is -0.410. It means our data between -1 and +1, it is normally distributed. And day 1 it is 1.095. It is outside the range -1 to 1. That is why this is not normally distributed. And graph also shown that there is positive skewness in our data. So this is positive skewness, and one value is 1.09. It is positive value. Here we can see 1.033. Again it is outside the range. So same as the day 2, through graph we identify data 1 only normal. Through value of skewness we know the data normal, but through graph and value of skewness and kurtosis, day 2 and day 3 data not normal. Now third is we should apply, that is KS test, and we should check our data through KS test. So KS test means p value should be non-significant. If our value p value greater than 0.05, it means it is normal, which is desirable for us. But when we check the hypothesis, the p value should be less than 0.05. But here we can see here, this is p value greater than 0.05. It means it is normal data. Here less than 0.05, it is not normal, and it is not normal. This is about the normality of the data. Now we should understand the homogeneity. What is homogeneous? Homogeneity tell about the disperseness of the data. Okay. Now this is the concept of homogeneous. Homogeneity means कि these are the observations. Means there the one, that is one music festival, another music festival, another. So there are some music festival in a x-axis. Okay. Now this y-axis ringing hours. If some people are attending music festival, this particular music festival, then we ask question कि do you feel about the program, that through ringing. So these people say that after 10 to 15 hours, means we hear the ringing of the music festival. This is our range. Okay. So and for another participants, we ask them, this is the range, maximum 20 hours and minimum about 12 or 13 hours. This is range. Third group, fourth group. Here we can see the range should be constant across the group. There are seven group, one group, two group. This range should be, means lower observation and upper observation. For example, in this particular group, I have five people. I asked one people ki, how many hours did you listen the ringing? So one person said 10 hours, another said 11, 12. So this is the range, means this is the range. This is range. All are the range. Range should be constant, means constant. This range should be same across the group. If range is, if range the variation of the range disperse, means it is, here range is this 5, here range is 15, 10, 15, 20. Here disperseness we are looking here, the data is more scattered, more disperseness. So across the category, our data not range not constant. So this type of data known as heterogeneous. Now, how to estimate through the SPSS? I am taking case study one, same case study. Through this particular case study, I will identify the normality and homogeneity of the data. Okay. Now I am showing the another slide, that is SPSS. Now I think you can look this slide, the gender, day 1, day 2, day 3. Okay. So I am finding here, I am finding the normality of my data. Now this is just now this is day 1, day 2, day 3. So we should keep in mind, while performing any parametric test, we will check normality of the data and homogeneity data. If our data normal and homogeneous, then we can use independent t-test, pair t-test. We can use analysis of variance. We can use repeated measures ANOVA. If our data not normal, not homogeneous, then we apply non-parametric test. For example, if we want to compare two groups, then we use independent t-test. But before using any independent t-test, we should check normality and homogeneity of the data. If my data not normal, then we will use equivalent to independent t-test in a non-parametric test, that is the Mann-Whitney U test. Okay. Anyway, so I am finding the normality and homogeneity of the data. So how will I find the normality and homogeneity? First of all, I will select analyze, and then descriptive, and then explore. Okay, there are the way to select or finding the normality and homogeneity. So first of all, I am checking the normality of my data. So I will select all the three variable into the dependent list. Okay, I am repeating again. So how will I do? Analyze, descriptive statistics, and explore. This is my route to performing the normality of my data. So I want to check normality of day 1, day 2, day 3. Okay. Simultaneously, I selected all and transfer into the dependent list. Now, statistics. So by default, it will give us descriptive. Now, graph plots, we want histogram. Through histogram we can identify. And third thing, that is the normality plots with test. So we find normality three ways. One is through cases normality plots with test. It means KS test and Shapiro test. Second is through graph, and third I told you the statistics, means descriptive statistics. So there are three ways to find the normality. So I will explain only three methods how to estimate normality of my data and then continue. Okay. So before this, because I will not okay here now, because day 2 and day 3 are missing data. If we have missing data, then we will tick option this, and we will tick here. You can see missing values. So you tick here exclude cases. If your case, if you are using a file which have some missing cases, then you should select it. If you do not have any missing case, then there is no problem. You by default it will give the exclude case list wise. But in my case study, day 2 and day 3 there are some missing data, so I will tick here exclude cases pairwise and then continue, and then finally I will okay. Then I will show you my result. I am stopping this slide and I am showing you the okay. But before showing this particular, I will calculate homogeneity also. Okay. So then I will explain both the homogeneity and normality. So now how will I find the homogeneity, then analyze descriptive statistics and explore. Same route. Okay. But we should keep in mind homogeneity can be found at least we need two groups for finding the homogeneity. If we are using only single group, we cannot find the homogeneity. So we need at least two categories. Gender means the dispersion of the data of male respondent and dispersion of data female. Okay. So we can find the variation should be constant across the group. So here for calculating the normal homogeneity, we need two groups. Now I transferred this variable, and then I will tick plots, and here normality plots with test, and second is untransformed. Here you can see leaven test. Leaven test through this particular, I will tick here untransformed and then continue, and after continuing I will okay. Then this is after okay, I am showing you the slide output. So I am sharing the output of my data, that is output. Where is output? I'm finding the output. So output, yes, this is my output. So okay, now we can see the output of my data here. So I told you to there are three ways to find the normality of the data. One is we will check normality of data through graph. So first of all we will see the graph, and then after graph we will check value of skewness and kurtosis, and then I am taking this one. This is the gender, and I am taking first this one hygiene. Okay. So I am explaining here normality of my data. So there are three ways to checking the normality through graph. So this graph should be normally distributed. I will double click, and after double clicking, I will select sorry. So histogram, I am again day 1, that is test of normality, that is the graph. Through graph we can understand. In this table we can understand there are three. Day 1, this is my graph histogram. This is normally distributed. We can see, we can double click and superimpose the normal curve. Okay. Now second is through value of skewness and kurtosis. So through descriptive statistics we can understand the values of skewness and kurtosis. So here day 1 score, test of normality and case processing. So here we can check in a 800 out of in a day 1 all 800 were present 100%. Day 2 only 264 were present, and day 3 only 123. Okay, here we can see the case test. Through case test we can identify the value of skewness and kurtosis. Here we can see the p value, it is greater than 0.05. It means it is my data is normally distributed. We should keep in mind for checking the normality, we want p value greater than 0.05. You can write anywhere. For checking the normality, we want p value should be greater than 0.05. But all the for example, I am testing the hypothesis, we need p value should be less than 0.05 to checking the whether this particular variable significantly contributing to other variable or not. Okay, so this is my method. And third, I told you the value of skewness and kurtosis. So through value of skewness and kurtosis we can understand, and all the values should be less than this is, you can see here, oh sorry, this one, not this one, another, yeah, here you can see the value of skewness and kurtosis, it is between -1 and +1. So our data in normal means there are three ways to checking the normality: graph, second value of skewness and kurtosis, and third is KS test. So we should report KS test. Okay. Now this is all about the histogram. And last, I will talk about the I will explain the homogeneity of the data. Okay. Now this is my data. I found the homogeneity of the data. How will I found the homogeneity of my data? This is my homogeneity test. Means through this table we can identify the normality case test, and we will check in out of the 6 only one variable, only one data, male data normally distributed, but rest of the data not normal. Okay, because all the 5 data value p value less than 0.05, which is not desirable for checking the normality of the data. Now second thing, we should check the second normality, and second is homogeneity. So through live-in test we check the homogeneity. We will read only this first line based on need. Okay, and this value should be greater than 0.05. Here we can see this p value, it is less than 0.05. It means our data, 1 day data only for male normal, but it is not homogeneous. For checking the homogeneity for assumption purpose, we need both the assumptions. It means our data should be normally distributed and our data should be homogeneous. So we should report only two things. One, for normality we should report case test value, and for homogeneity we should report value of live-in test. Okay, so and both the value should be greater than 0.05. Now case is, if our data not normal, not homogeneous, then what should we do? Now if our data not normal or not homogeneous, then we have three methods to correct our data. One, we will correct our data through one method, that is log transformation, square root transformation, and inverse transformation. Okay, so after transformation we can check our data whether our data normally distributed or not. Okay, now first thing is, first of all we should check our data normality and homogeneity through KS test and live-in test. If our data not normal, not homogeneous, then we will correct our data. Okay, so I am taking same case study for correcting data. How will we correct our data? I am taking same example for correcting our data, and then we will see the graphs. Okay, so I will take only 5 minutes more. You just keep patience, and I am how to correct the data. So this is day one data and day two data. So I am taking log transformation. There are three ways to correct data: log transformation, square root transformation, and inverse transformation. This is the transform. So I will transform log transform compute variable. Here I will write here log 2. Log 2 means log 2 day 2. Uh, Log means log transformation, 2 means day 2 data. So for my convenience, I have written here log 2. I will copy and paste. I will copy and paste here label, and then continue. I will select. I will tick all and select the log. Okay. So log is log 10. I will select log. Where is log 10? Here I am selecting log 1, log here. So I will select day 2 data plus 1. I am writing here plus 1 because log 1 value 0 and log 0 value infinite, because in our data values lie from 0 to 4. That is why I have written here log. Okay, so here log day 2 and 1, that is the okay. And for day 3 data, for day 3 data, I am checking log, and another method, that is the square root transformation. Second method is s I am writing here sqrt. Okay, so first of all I will reset it. I will write here sqrt2, and then copy and paste into the type and label. So here I will type, and this is label continue, and then I will select here this one square root sqrt. We can find here sqrt, I think sqrt. Okay, I will transfer it into here above table, and then sq day 2. I will not write anything here as it is. I will take square root of this, and then okay. So third, inverse transformation. I will do inverse transformation. How will I do the inverse transformation? So in inverse transformation types compute, or here I will take inverse invs. Okay, inverse. So I will select copy and paste into this particular label box, paste, and continue, and then inverse q. So 1 by in a bracket I will transfer day 2 data plus 1. Why I am taking plus 1 here? 1 by 0 means infinite. If my data not contain 0, then I uh, I will not take the 1 value. Okay, the 1 by day 2 plus 1, and then okay. So my data, we can see my data this. So there are three variable I created. My table log 2, square root 2, inverse 2. Now I am making the graph of all the three variables, and then we will see how this graph comes. Okay, now but only I will take only 1 or 5 minutes, because you have already sitting last 3 hours, and I salute your patience. You are uh, watching this lecture patiently. So I will create the histogram. I'm checking here histogram, this one. So now I can take here the I can make, but I will make my histogram through this way also. Here descriptive statistics and explore. Okay, so here I will not take gender here. So plot, I will take only histogram. I don't want right now normality. I want to check only histogram here, then options, and then by default exclude cases pairwise, and okay. So I am showing you my output, how my data comes after the correcting the data. So we can see here, this is no, I think, is it visible to you? I think you can see uh, day one, sorry, my mistake. Actually, I did not entry the my data, that is log data I did not include. I am sorry for. So I will include this. So analyze, descriptive statistics, explore. So I will not take all variable because I have taken earlier. So I will take only three data, this all the three new, and continue, and then plots, and then histogram, there is no problem, and then okay. Now I am showing my data. Okay, I am sharing my slide, and this is my output. Now we can see this. This is my day 2 output for applying the log transformation, for applying the square root transformation. Now my data this. Earlier it was not like that. Is it clear? So through log transformation, now this is the third method, that is inverse transformation. My data looks like this way, and for I think square root is much better than the others. Okay, thank you very much for listening me patiently last 3 hours, and thank you. So I am stopping my lecture here today. Thank you very much all. हाँ जी सर. सो मैं अब अपने ऑर्गेनाइजर को आमंत्रित करूंगा, वही अब इसको थोड़ा देखेंगे. आज का जो सेशन है वो हम
Thank you so much, sir, for your wonderful session. And
okay.
by seeing the reactions of the participants in the chat box, we are very sure that it's a wonderful session and it's very useful for all the participants. And I request to all the participants that don't worry, we will give all the materials, all the recordings to you. And thank you so much, sir, for your.
Okay, thank you, sir. Thank you very much, sir.
Okay.
Okay, we will meet again. Okay.
Okay, sir.